as we move forward. They are the feedback feature, Q&A, and lost audio. The feedback feature is located in the upper right corner. As this is a streaming webcast, this is the best way to communicate with the presenter and moderator. As you can see, if you run into issues, please select the appropriate item from the drop-down, and the moderator will reach out to assist you as soon as possible. Next, we'll look at the Q&A feature. We definitely encourage questions throughout the presentation. You would simply click into Q&A, located in the upper left toolbar, type your question, and click the Ask button. The questions go to the presenter and moderator, and please note all questions are held until the end of the webcast. The last item we wanted to talk about was voice and video, also located in the upper left toolbar. Sometimes in a streaming webcast environment, the audio will drop. In order to correct the situation, click Voice and Video. You will see this red error message. You would click the X to get out of the error message, and then click Join Audio. As you are reconnected back to the webcast, you will be able to once again see and hear the presentation. We look forward to your participation in the upcoming webcast, and thank you.
Thank you all for joining us for today's Azure Architecture Series webcast, Windows Azure Communication Architecture and Design Patterns, presented by David Pallman. My name is Amy Nelson, and I'm the Marketing Coordinator for Neudesic and the moderator for today's webcast. This webcast is presented by David Pallman, Neudesic's General Manager of the Custom Application Development Practice. We are very excited to have him present for us this morning. Today's webcast is a part of our Azure Architecture Series. We will be hosting the next webcast, Windows Azure Security Architecture and Design Patterns, on July 13th. We will be sending out more information about this webcast along with the webcast recording. If you are logged on, you should all be able to see the title slide that states Neudesic. There was a brief intro earlier regarding the features within Live Meeting. To briefly recap, we encourage you to ask questions throughout the session by typing them in. To ask a question, click on the Q&A verbiage located in the toolbar on the top left side of your screen. Type your question, then click the Ask button. Please note that all questions will be held until the end. We will also be using the seating chart featured within Live Meeting. Changing your feedback color within this tool provides feedback to the presenter. To provide feedback, click on the Feedback menu found in the upper right-hand corner of your screen. Select your feedback color. Your seat in the conference center will display your selected color. Lastly, this webcast is being recorded and will be available via the Neudesic website. We will email you when the link is available. If everyone is ready, please make sure your seat color is green. And at this time, I'd like to turn our presentation over to David.
Thank you, Amy. Hello, everyone. I'm glad you're here. Let's look out the window. It looks like it's a beautiful day to do some cloud computing. So let me just share my desktop here, and we'll get started. So as Amy said, we're here today to talk about the Windows Azure Communication Architecture. This is the fourth in a monthly series we're doing on Windows Azure Architecture. In the past months, we've reviewed the compute architecture for hosting, storage architecture for non-database primitive storage, relational data architecture, and now we're talking about communication. So first off, often when we talk about Windows Azure, we often introduce some new capabilities for the cloud, and that's mostly what we're going to do today. But before we do that, I always want to make sure that everyone understands that nobody is telling you you have to change the way you do communication. You can keep doing communication for your applications in the cloud the way you have been if you choose to. In the case of things that you host in Windows Azure, or what we call the Windows Azure Compute Service, you have endpoints available, HTTP, HTTPS, or TCP. You can have public endpoints, such as you might make available for a public website or public web service. Public endpoints are internet accessible and load balanced for you automatically. And there are also private endpoints. These are endpoints that you might use, for example, for a web service that you only want your own application to be able to access in the cloud, but not outsiders. And so standard communication for that's IIS hosted, as we're doing what's called a web role, or you're reaching out to external services and such, all of that is really business as usual. So the way you're used to communicating is certainly valid. Another way you might communicate in Windows Azure is through storage queues. We have the Windows Azure Storage Service gives us basic simple queues. And you might use those for any of the reasons you would use queues in the enterprise, but another reason you might use them is to interconnect your roles in Windows Azure hosting. So, for example, if I had a web role in the cloud that is my front end, or website perhaps, and I have a worker role, which are background workers, also in the cloud. Both of them are farms with a number of instances or variable and elastic. How do I communicate between them? Well, one common pattern we're seeing is people use queues to have the front end pass task messages to the back end. So a few different ways to queue communication, but the one that we really want to focus on today is the one that's most likely new to you, which is called the Service Bus. And that is part of the AppFabric area of Windows Azure, which I like to characterize as sort of the industrial strength, enterprise-ready services in the cloud. AppFabric includes not only Service Bus for communication, but also the access control service and also caching service. So at a high level, the way to understand Service Bus is it's using the cloud as a relay for communication. So there's a number of parties out there, and we'll get into the specifics of how this all works in a few slides hence. But basically the idea is that the cloud becomes a very interesting intermediary through which to flow your communications. So here's how Microsoft described it out of their Windows Azure Training Kit. Service Bus enables various communication protocols and patterns for developers to engage in reliable messaging. It provides messaging connectivity across different network topologies. It provides secure messaging. And it enables hybrid applications that span on-premises and the cloud. Now that's a mouthful, so I want to kind of dissect that and make it all clear to you. And I think a good way to do that is to look at some of the problems that the Service Bus solves. So I want to talk about 4 of them. The first is that provisioning is difficult. The second is that networks can be challenging. The third is that there's a need for sophisticated communication patterns. And the fourth is that messaging needs to be secure. So this first one, provisioning, is difficult. So if you electronically communicate with other organizations, I'm thinking here it could be customers, it could be partners, suppliers, vendors, other members of your industry. How does that usually happen as the electronic connections happen? Well, maybe you have something in place that's already set up for that, but a lot of the times what happens is whoever has the bigger, badder IT department has to get into the business of provisioning VPN connections for new partners, or creating custom web services with custom security for each new partner or customer. And all those things are doable, and how to do them is known. It's still a lot of work. It would be nice if that could be simplified, made more efficient, not require custom individual human attention every time. Well, in the case of the Service Bus, introducing the cloud as an intermediary changes the whole picture. So just imagine you had two systems that are in different organizations, and these 2 applications are internal, so they can't reach outside the firewall, they can't talk to each other. What we can do with the cloud is use the cloud as this relay where both parties can reach out to the cloud and they can communicate with each other. And it's very similar to how instant messaging technology works, where lots of people can talk through IM even though they're at different locations. They all reach out and connect through a cloud as an intermediary. And so that opens up all sorts of new capabilities for you that we want to explore. Second challenge is that the networks can be very, very challenging, especially in the federated communication scenario where multiple organizations are involved. You've got all sorts of armor, and for good reasons, in your enterprise. You've got NATs and firewalls and proxies, and if you're going to reach out to another organization, also through NATs and firewalls and proxies, firewalls are there at the corporate level, they're at network level, they're there on your own machines, they're just all over the place. And so it's a bit of work these days to reach through all of that under the proper circumstances and communicate. Again, doable, but always requiring a fair amount of work. The nice thing about Service Bus is not only is it expert at moving through NATs and firewalls and proxies, but it does it in a way that whether you're a sender or a receiver in conversation, as far as your IT department is concerned, your application looks like port 80 outgoing web traffic. So you really just look like a web browser. And because of that, there's no special IT infrastructure configuration required to use Service Bus. IT does not have to open up a port or do anything special, really. It just works. The third area is that there's a need often these days for more and more sophisticated communication patterns. For a long time, we've had request reply, or one-way messaging, or perhaps duplex messaging, and that certainly covers a lot of scenarios. But when you're doing federated communication in particular, you have scenarios such as supply chain management, where there are many, many parties and they need to inform each other all the time about things. Using these more primitive building blocks of more primitive patterns of one-way messaging and request reply, you end up building a big cobweb of interconnections, and it can be kind of fragile. If something moves or changes, it's always a lot of maintenance headache to keep all this up to date. But the cloud, though, once again, using this cloud as a relay, it supports certainly those patterns, but more sophisticated patterns as well, such as publish, subscribe, or you might know it as eventing, where there can be a one-to-many relationship. So here we might have a machine sending a message to Service Bus, and then we might have multiple parties listening on that conversation and all getting a copy of it. And the other thing about this that's very nice is that it's not easy to target individual machine addresses. Because the machines are connecting into a conversation, the addresses that matter are the address of the conversation in the cloud, not the individual addresses of machines who are going to receive the communication. Third area that's important is that messaging needs to be secure. In the case of Service Bus, it is secured with its sister service in the cloud, the AppFabric Access Control Service. That's something we're going to cover another week. But the Access Control Service is a very, very, very versatile cloud service that really, its mission is to support the world security schemes, everything from domain security to web entities. And so securing Service Bus with that gives you a wide range of options for how to secure your conversations. So in case you're worried about security about all this, because I just mentioned how marvelous Service Bus is at getting past your defenses, all of the parties in Service Bus connection have to authenticate. So you are in control of security. You don't need to worry about outsiders getting access to something they shouldn't. So let's see how this all works in practice. Let's say that in your data center you have a line of business application with a line of business web service, and some partner out there has an application, perhaps a mobile device application, and they want to access it. But your web service is internal. You don't really want to expose that outside your firewall, and their applications also aren't necessarily publicly accessible. So, previously the answer was, well, somebody's going to have to change that arrangement, or nobody's going to be able to communicate. But with Service Bus, we can do this. We can have both the line of business web service authenticate and then connect to the Service Bus. And we can do the same thing with the partner application, authenticate and then connect to the Service Bus. And now they can communicate. And the Service Bus is so good at communication that once it's established this sort of communication, it can analyze the network topologies, and at times it can actually find a way to directly connect at times. So if there's a way to optimize that communication and make it as efficient as possible, Service Bus will do that automatically for you. So some common patterns for working with Service Bus. One is eventing. So this is where you do your one-way communication, a unicast or multicast situation where you're going to send a message and go to a bunch of receiving parties. Another is service remoting, where you're doing things that look like standard web service work, like request response or duplex, and you've got the usual, for example, using WCF, the usual WCF artifacts like contracts and schemas. But the communication, rather than being just something like HTTP in between, is Service Bus in between. Because of that, the client and the service can reach each other, even though they might be in topologies where normally that wouldn't be possible. Third pattern is tunneling. This is where you take some other protocol and you send it over the Service Bus as a transport. And again, an example of that might be something like a Neudesic connection between a client and the database, where again they couldn't normally reach each other, but the Service Bus in between can make that happen. So what's it like to program Service Bus? Well, you can, as it originally was designed, it was something you got at the Windows Communication Foundation, WCF. And that's still perhaps the first-class way to use it. But it was important, Microsoft felt it was important that Service Bus, in line with the whole mission of Windows Azure, is to be accessible to very open public protocols like HTTP REST and such. So the Service Bus is actually also accessible through REST HTTP. So if you have something like a mobile device application, right, that might not have the .NET framework on it or WCF, but it can issue web calls. So two ways to do that. There are special bindings you use in Service Bus, such as NetTCP relay binding, NetTCP event binding, and there are web versions as well that do the RESTful interface. So let's look at a demo or two of this. The two demos I'm going to show you are out of the Windows Azure training kit. There's a lab in there called Intro to Service Bus Part 1. I'm going to show you exercise 1 and exercise 3. Give you an idea what this all looks like. So the first example is going to be just using Service Bus as we would use a regular service. it a little smaller. So what we've got here is we've got a solution with a standard WCF service and a standard WCF client. The service has a single method called echo, which doesn't do anything terribly astonishing. It just returns back the text it got. And the client program creates a connection to this. It just has a security to proffer. And but again, it's just a standard create a connection to a WCF channel and consume it. And again, nothing terribly elaborate here other than the fact that we do have some security that we're specifying. In the app config, though, we can see some differences here. So here you see we're using the net TCP relay binding. That binding is your tip-off that we're actually using the service bus for communication rather than just a direct transport protocol like HTTP. So let's go ahead and run this. So our service is just connected to the service bus. And you see I'm displaying here the special URL for the conversation. That's something we set up in the portal. I'll show you that afterward. And now we can have our client interconnect here. It can take a few seconds for it to connect. And now we can bravely try some text, such as hello. And we can see that we talked to the service and that good. So all very straightforward. And so what you might say, I can do some standard WCF. What's so magical about the service bus doing it? Well, what's so magical about it is, if we were all sitting in a room here, I could give one of you the client program and one of you the service program, and you can each go your separate ways and take those programs somewhere else, to some other organization, your companies or your homes, and run the client and service. They still be able to talk to each other without you changing any addresses, without you changing any configuration. They'd still just continue to work. In fact, one of you could jump on an airplane and fly to another continent, another country, and again, these programs, while running, would still be able to communicate to each other, even though you've changed the location and the domain that you're running them from. No addresses have changed or anything. They're both targeting the cloud as a central intermediary, and it just works. And I always understood that intellectually, but last December I had a chance to do a bunch of Windows Azure training on behalf of Microsoft, and we were on a bit of a train wreck with schedule. So I remember finishing up a demo of this in LA, had to immediately jump on a plane for Europe, and a couple days later I was doing this in Germany. I didn't really have a chance to move all of my demos and such around. Everything just worked. Everything just moved with me, and so it really is a very interesting capability we have here that a new set of tools that we haven't had before. Okay, so let's close this down. So as far as how we specify what's going on here, we here in our program code, we are specifying, first of all, a service namespace, which you saw on the screen earlier. It's a special format. And then we've got to specify some security information. Here we're specifying a shared secret. So what is that information? How do you know what it is? Well, in the Windows Application Manager portal, if you go to the Service Bus area, and then take the subsection also called Service Bus, you'll have a chance to set up one or more namespaces for your service. And you see I have one here, the one I'm using. When you do that, you're going to get endpoints for your communications, but also management, and you can get keys. And so by specifying the right Service Bus endpoint name and the right management key, that's really all you need to do. All your programs can then get out and talk to each other. It's that simple. Again, you're not targeting the addresses of any of your parties that are communicating, so that's so nice, very nice that you can not have to keep track of the addresses of the computers you're talking to or figure out a way to reach them. They can all just reach the cloud. So it works out very nicely. The second demo I want to show you is this eventing pattern where you're doing multicasting. So here we're going to take, this is also from the Windows Azure Training Kit, Intro to Service Bus Lab. This is from exercise 3. And this is kind of similar, except we don't have a client program and a service program anymore. We have just one program, which is just a simple chat program, and we simply want to spawn as many of those as we want to. So I'm going to launch 3 of them here. And you'll see that in the config, now we are using the net event relay binding, which gives us this multicast behavior. And the actual service is a very, very simple one. It just has a few methods for saying hello, saying goodbye, and then putting out a message. And let's kick this off and see how it works. First instance, I'll call my chat session test, and I'll call this first person Archie. Okay, and it'll take a second to connect. And we'll launch a second instance. Same chat session name. We'll call this one Betty. And that'll take a couple seconds to connect. And finally, a third one, test. This one, Richie. So as you can see here, hopefully, from the displays, we have end chat sessions up. Again, we've got as many as we want. And if we go to one of them and say, hello there, you see all the parties get the message. And we can leave. The other parties won't see that. So very small amount of code here, and yet we have something that's pretty amazing. Not only do we have an end-party chat program, which kind of would have been harder to write in the past, but again, these parties could be anywhere around the world, and just have no problem communicating as long as they have internet access. So definitely a brave new world in terms of communication and the new capabilities that we have here. So just to summarize the features at a high level in a service bus, a few things it has I didn't show you, but just you should know about. There's a way to register endpoints and discover them. There is a central registry. There is federated security access control service. There's lots of different ways you can secure this communication. So the base messaging is volatile messaging, meaning best effort. So synchronous messaging is going to give you the request response with a duplex pattern over TCP or HTTP. You can do a unicast multitask type of eventing, as you saw, or we can do TCP tunneling, where we take another protocol and tunnel on top of TCP. There's also a feature called message buffers, and that allows you to do a bit of asynchronous messaging, or to handle the disconnected case. If one of your parties is disconnected for and this is for a short period of time, you can actually still use Service Bus if you take advantage of the message buffer feature. But we have some new capability that just launched in the Community Technology Preview called Durable Queues. And we're not going to go into big detail on that, really because I haven't used the feature yet, but we will probably do a future webcast where we go into it. But just at a high level, we already have queues in Windows Azure Storage. Simple queues, 15 cents a gigabyte per month for storage, 8K maximum message size. You kind of have to poll them to check them. So why do we have another set of queues? Well, these are extremely mature enterprise queues. So if you use technology like Microsoft Message Queue or IBM Queue Series, if you've been missing features in Windows Azure Queue Storage, such as poison message detection and an event-based message receipt, and just the really advanced things you would get from a queuing system, larger message size. If you've been missing all that with the primitive Windows Azure Storage queues, then this is for you. Service Bus queues are extremely elaborate. They're durable, first of all, so whereas the other messaging in Service Bus is volatile, this is more reliable and guaranteed. Not only do you have all the features you would expect of a mature queuing system, but you also have enterprise Service Bus features. So if you're familiar with the ESB products, you might be used to things like subscriptions and topics or filters. An example of a filter would be I have a queue full of orders, but I don't want to get the next item off the queue. I want to get the next item off the queue that is set for express shipping. So I can set a filter condition and zoom in on sub areas of my queues. Schedule messages where you defer the queuing to a certain amount of time. Session support, transactions atomicity. Very, very sophisticated stuff here. This came out recently. Can sign up for that and play with that, and encourage you to take a look at it. So if you're an industrial strength queuing person in the enterprise, and you felt a little bit of a disconnect on the Windows Azure queues, then you definitely want to check out Service Bus queues. Okay, so then what are the scenarios for Service Bus? Well, first off, you can use it from cloud applications. You can also use it from enterprise applications or hybrid applications that span perhaps both. So it's usable in and out of the cloud. So you might use it when parties can't ordinarily reach each other. So for example, let's say you need to access an internal web service from the cloud that you can't normally reach and other options are open to you. You're not going to put the web service out there on the DMZ. You don't want to do a VPN connection with Windows Azure Connect, so this is another option for you. Just reach through with Service Bus. Another would be where you need to connect internal apps from multiple organizations to each other. Then you might find a good scenario for Service Bus is when you need very sophisticated messaging patterns, when request reply or one-way messaging is not enough. That might come up in the multiple party scenario, such as a supply chain management situation, or just any kind of multicasting need you might have. Service Bus would come in handy when you need easy routing across firewalls and apps and proxies. So if you need to easily provision customers to partner organizations electronically without a lot of fuss, when you don't want IT to do special work setting up ports or deploying things to DMZ, Service Bus to rescue. And then if your machines move around, or your software actually might be on different machines from time to time, or the addresses to reach them just aren't constant, well, you can do away with addresses with the Service Bus. The only address that everybody needs is the central one of the conversation in the cloud. So if we put this in terms of design patterns, we have the AppFabric Service Bus, one of the services in the Windows Azure platform. You create AppFabric projects, or really namespaces in the portal to have a identifiable hub through which you can route messages. One of the patterns is eventing, one-to-many communication. Service remoting will connect the client service across topologies that normally couldn't reach each other. Protocol tunneling will run other protocols on top of TCP. Service Bus message is a message envelope that you send over the Service Bus. Message buffer is a feature for handling the temporarily disconnected scenario. Queues are a new feature, industrial strength. Service registry and service discovery lets you put your namespaces out there to be discovered. And an AppFabric subscription is a purchasing agreement to get access to the AppFabric features. A really good resource is Windows Azure Training Kit. I've just shown you 2 demos from it. There are several presentations in there that are useful. One is the introduction to AppFabric, and there's one specifically on the Service Bus. There are several labs, Introduction to Service Bus Part 1 and Part 2. The 2 demos I showed you were from Service Bus Part 1 lab, exercises 1 and 3. If you aren't active on Windows Azure but are curious about it, you can get a 30-day pass. You can get that off my blog at davidpallman.blogspot.com. There's one way to get a 30-day pass. So, at this point, we are ready for some questions. So, you can either ask those through audio, or you can use the Q&A mechanism here. I don't see any at the moment, so we'll just linger for a minute or 2 and see if any come in.
Thank you, David, for this awesome presentation. Sorry, we did have a few questions come through. To ask a question, please click on the Q&A verbiage located in the toolbar at the top left side of your screen. Type your question and click the Ask button. How is the Service Bus priced?
Okay, good question. What does this all cost? Let's go here to the Windows Azure website. So first of all, if you're interested in how any of the Windows Azure platforms price, Microsoft recently launched a brand new, very simple to use Windows Azure pricing calculator with sliders here, and you can get that at azure.com under the buy link. The Service Bus is actually sold in what are called connections. This is, sometimes it's a little confusing to people, but the way it works, and you can see this under the pricing sheet on azure.com, is you buy Service Bus in terms of connections. Now, you might expect that it's based on the number of messages you send or the size of your message data, but it's actually based on the number of connections you make over a month. And so you can buy these connections one-off. It's a little expensive at $3.99 each, but you can buy packs of 5, 25, 100, or 500, and that's where you really get the economy.
Great, thank you. Another question that did come through, is Service Bus a security risk since it can get past firewalls?
Great question. Service Bus has security risks, since I made a big deal about how it fears no firewall or other things and can just reach across them. Is that a big concern that the IT department should be worried about that? Yes and no. No, in the sense that your communication is secured. As I mentioned, it's integrated with the access control service, and so all the parties have to have some sort of credential in order to communicate. But it is one more example in the cloud where some of the things that traditionally have had to be enabled by IT can be enabled by developers. And so, yeah, you might want to have a policy discussion internally about who needs to be informed about things like that and such. So, yeah, there's a little bit of a shift in that there's a little bit more direct empowerment to the developer. But no, not inherently insecure. It's just different. And I think we have one other one here. How do you compare Service Bus to other ESB tools such as TIBCO? Well, I'm probably half qualified to answer that question. I did in a former life work on the ESB, but I haven't actually used TIBCO directly. Most ESBs get involved with interesting patterns of communication. They often let you interconnect a lot of different types of systems with different protocols, and they can mediate the differences there. Sometimes there can be mediation of transport, mediation of method format, of security model, and often they have pipelines where you can do interesting things. The Microsoft product closest to that would be BizTalk Server. The AppFabric team has announced a bit of a roadmap, and so this is one of the things that is coming in the future, what they call integration services. And so I think what you're going to see is that Service Bus, which started out with interesting but volatile messaging, now has durable queues and preview. And I think what you're going to see, from what I understand, beyond that down the road, is that more and more of the things you could do on a product like BizTalk will be available in the cloud services. So it wouldn't surprise me if down the road a little bit we have integration pipelines where we're not just passaging messages through the cloud, but perhaps we can act on them while they're en route. But we don't have any hard dates or any specific future promises there, so we really just need to watch for new news of these things, which often comes up at the various conferences, and see how that progresses.
Perfect. Thank you, David. If anyone has any more questions, please feel free to type them in at this time. In the meantime, I'm going to click through a few polling questions, and we would greatly appreciate your feedback. First question, was this content helpful for your business? Yes or no? Perfect, thank you. The next question, please rate the presentation content, excellent, good, or poor. All right, and last question, would you like us to schedule a follow-up, yes or no? Perfect, thank you. We will be forwarding the link to view a recording of this webcast once it becomes available. If you have any further questions about this presentation, please feel free to email David Pallman at the email address provided on his slide. Again, thank you so much for everyone for joining us, and we look forward to seeing you on our next webcast. You are now free to disconnect. Thank you.